Dear everyone, my name is Nargis Khalmamatova. So I'm a fourth year student at New Uzbekistan University, and I'm going to be a course instructor for the introduction to water systems, to water sector in Uzbekistan for this course. So a little bit about my background. So far I have been to many places for scientific internships, including Germany, USA, and currently I'm in Astana, Kazakhstan, doing my research on removal of dyes from wastewater. And basically, I'm very much interested in water structure of Uzbekistan, and I have learned a lot about it throughout my research and my professional career. I have been working and doing internships in such places as Usu Taminot, the organization that provides drinking water to citizens all over the Uzbekistan, and I have also been working part-time in Hydrometeorological Institute. This is the research institution that analyzes the quality of surface water bodies, and also I have been working in Ministry of Water Resources the last summer, and have been learning a lot about the water management in our country. So that's why throughout my work experience I have collected some amount of knowledge that I want to share with you this coming week, and hopefully we will get along by the end, and hopefully it will be a very nice, interesting introduction to water sector in Uzbekistan. So let me just make sure that no one else wants to enter. Nice. Okay, so let's start the lecture then. So today is the day one, and we're going to talk about the fundamental structure of water body in Uzbekistan. Where does the water originate and where does it go? And how it fades from Uzbekistan, how it enters Uzbekistan, and how it leaves Uzbekistan. So today we're going to talk about mainly geography. We're going to answer such questions as the ones I have already mentioned, from where water comes and where it goes. And if you have the patience to stick till the end, then we will have the chance to discuss such cases as RLC and see its history real time. And hopefully all the knowledge that you will collect throughout this lecture will be put to use in order to learn about RLC and to make your homework, which will be given to you at the end of this lecture. So basically this is very popular map that is known to many people that are in Uzbekistan. So and basically here you can see that throughout Uzbekistan we have two main rivers. This is Amudarya, the biggest one that you can see here, and this is Sirdarya. This is the longest one, but in terms of the amount of water, it is lower than Amudarya. And as you can see, these two big rivers are flowing all the way throughout the Uzbekistan, and they are originating in different places. Amudarya is originating in the mountains of Tajikistan, and Amudarya isn't always Amudarya. Before Amudarya comes to existence, there is a river Vaksh and Panj. If you can see, these are the smaller rivers that are originating right inside of the mountains of Tajikistan, and after they are united in this place, Amudarya comes to existence. And then both Amudarya and Sirdarya are rivers that are crossing. I should make something for this to accept the students. So both Amudarya and Sirdarya cross borders of different countries. For example, Amudarya crosses the borders of Tajikistan, Afghanistan, Turkmenistan, and Uzbekistan. Here you can see. So this is the Afghanistan part, and then it's Turkmenistan's part, and after it passes the Turkmenistan, the Amudarya comes to Uzbekistan. So first it leaves Tajikistan Tajikistan, then it enters Afghanistan, then Turkmenistan, and Uzbekistan receives the water of Amudarya as the last receiver. And then supposedly, as it was said by the nature, Amudarya has to flow back to Aral Sea in order to fill Aral Sea with water. So this is the path of Amudarya. Now, if we go to Sirdarya River originates in the mountains of Kyrgyzstan, our other neighbor. So Kyrgyzstan mountains, first, Sirdarya originates from the river Narin. So here you can see Narin. And then after it passes through this step, it already turns into Sirdarya. Yes. So Sirdarya, as soon as it crosses the borders of Kyrgyzstan, it enters Uzbekistan. Here you can see that it enters Uzbekistan and passes through our region, which is called Sirdarya. And here we start basically taking water from it. And then we also contribute to Sirdarya. Not only do we take the water, but we also contribute to the Sirdarya. So if there are students living in Tashkent, you know that we have Chirchik River. So Chirchik River and Akhangaron River that are originating in the mountains of Uzbekistan. So these are the two rivers that are owned by us. This is our water, right? The water doesn't have the owner, but it's originated in Uzbekistan. So it flows to Sirdarya. So this is the contribution of Uzbekistan to Sirdarya's water. And then it crosses the border of Uzbekistan and then it goes to Kazakhstan. And in Kazakhstan, so here you can see that Kazakhstan also takes a lot of water from Sirdarya. And then already a smaller portion of Sirdarya goes all the way up. And joins the North Aral Sea, the upper part of Aral Sea. So this is something that is good for the eye and it's very viewer friendly, I would say student friendly map in order to see the water. However, there is also another type of map that is shown here that shows all of the junctions, all of these small lakes, reservoirs, canals and rivers in the whole Asia, I would say Central Asia. So you can see that in this map we already have China. We have all of the river bodies in Kyrgyzstan, Tajikistan, Afghanistan, Turkmenistan, Kazakhstan and Uzbekistan. So this map is more comprehensive, I would say. It has more data. So for example, if some of you in the future want to make research in water, then I would probably suggest you to use this map because it has more information and it is more accurate in terms of connections and other things. Yes, it shows more things, but we are not going to get into detail in this map because many of the most important things we have already discussed here. Yes. So the summary, our waters are being mainly originated in the mountains of Tajikistan, Kyrgyzstan and very small portion in the mountain of Uzbekistan. And then all the water flows downhill and is supposed to go to Aral Sea and fill the Aral Sea. And on its way to Aral Sea, all of the people of Central Asia and Afghanistan are trying to get that water for their irrigation and for their day-to-day purposes. Yes. And basically some statistics for you. So Uzbekistan really depends on the Amudarya and Sirdarya, and basically 80% of water that comes to Uzbekistan is being originated in the territory of our neighbors. And that's why we have to be very diplomatic with our neighbors, very friendly, diplomatic, because if something happens and I don't know, we get into war or our relationships will be not that good, then Uzbekistan might be cut off from the water, which is not that good. Yes, so in order for you to be able to not only know about water geography, but to be able to communicate about water geography, you have to know a little bit of terminology. So in fact, there is like a very huge amount of terminology in water geography, but there is like very small amount of it that I think should be known to all of you. So basically we have rivers, canals, reservoirs, lake, sea, and ocean. And right now we're going to discuss every one of them in detail. So river is something natural and flows downhill. It's like Amudarya and Sirdarya. So for example, in order to show you, I have the map of Uzbekistan. So I'm using this app which is called Google Earth, and this is really a cool app for you to, if you want to visualize the earth and see it real time. It's a really cool app. I really recommend you to download, and you will need to download it for your homework. So yes, so right now we're going to look at different bodies, different water bodies, in order to learn the terminology. So for your orientation, so here is the Aral Sea, here is the Karakalpakstan, here is the whole Uzbekistan, as you can see it, yes. And so basically, if we want to talk about the river, then let's go and look at Amudarya. So if you can look, then this green strip of land here is Amudarya. So this is green because people have made irrigation lands all over this Amudarya. So this one that you can see right now is Amudarya. So, and Amudarya. So here is, so here is the origins of Amudarya. Let me invite one of your friends. No? I heard something. Okay. So here is the origin of Amudarya. And here you can see that Amudarya is being originated from these two rivers. Yes. Amudarya is being originated from these two rivers that, as we discussed, is Vaksh and Panj. Someone wants to enter or what? Yes. So basically, the Amudarya here, there is a big elevation, so you can see the mountains. It's being originated in the mountains, and it flows downhill, and it's supposed to go to Aral Sea. Why do I? Okay. Wait. Yes, and it's supposed to go downhill to Aral Sea. So it originates somewhere naturally without the intervention of a person, and then it originates downhill. So this is a river. Now there is a canal. Canal is also a path where water flows, but it's made by a person. It's a man-made, but it also flows. If you want to look at canals, then we can, for example, are there people from Khorizm? I hope there are. So if we look at Khorizm, then we can see here Urgench, Yangi Bazar, Shavat, Khonqa. Yes. And so here again is our Amudarya. So here is the Amudarya. And all the way from here, we can see a perfectly straight strip of water. Here is the river, which is natural, and here is the canal. And this is made by a person, but it also flows downhill. And then we have a reservoir, and reservoir is something that is also made by a person in order to save water. So we don't know what might happen in the future. That's why we need to keep the water intact. So do we have a reservoir here? We should have one here. For example, Kashkadarya has the most important reservoir. For example, the most prominent one could be the one in Tashkent, Charvak, that everyone knows about. But I would also like to show you the one in Kashkadarya. So are there people from Kashkadarya? So for example, here, can you see this big body of water? This is Tali Marjan Reservoir. This reservoir brings water to whole Kashkadaria. Here, this is a big water. This is a big body of water. Yes, and here you can see the points where this thing is being filled. And this Talimarjan reservoir is taking water from Amudarya, basically. So here is Amudarya flowing, and here is our Talimarjan reservoir. And there is like a lot of pumps that pump the water uphill. For example, here you can see the pumps here. If someone is from Kashkadarya, then you should know that there is a lot of electricity. There is a lot of events when electricity is cut off. Basically, this is because these pumps are very energy thirsty, and at times, if there is lack of electricity, the whole region is being cut off from the electricity in order to feed these pumps, as a matter of fact for you. So this is reservoir, this is man-made. And here you can see another canal that is being drawn from this reservoir in order to feed these irrigation plains. Yes. Then we have a lake. So lake is something natural and it's totally surrounded by land. So Aral Sea, that we call sea, it's not sea, in fact it's a lake. Yes. Oh. Aral Sea that used to be a sea. Yes, it's a lake. It's formed naturally. This is formed naturally and it's surrounded by land, meaning it doesn't have access to water. It doesn't have access to ocean. There is no nearby ocean, there is only land. That's why it's a lake. Caspian Sea is not sea also. It's also a lake. Caspian Sea is also a lake. Why? Because it doesn't have access to water. Is Black Sea a sea or lake? I don't know whether Black Sea, Chorno More. If you have watched some Turkish soap opera, then you should know about Black Sea. So it seems like it's being cut off. So it also, I know, here is a narrow strip of it going to the ocean. So Black Sea is a sea because it is connected to ocean. Yes. So a lake, as I said, is a water body that originated naturally and surrounded by land. And then we have a sea. It's also a water body, but it's also originated naturally, but it's connected to a sea, to an ocean. For example, this one is Balearic Sea, Tyrrhenian Sea. So there are a lot of seas here, and they're all sea because they're connected to ocean. Yes, they're connected to this ocean. Yeah, and then we have the ocean, and ocean is the big water body. Yes, so here is the big water body that is that is not connected to every word, but it's ocean. Yeah, the ocean we all know. So basically this was a little bit of terminology that everyone should know. The biggest important thing is to know the difference between lake and sea. Yes. Okay, we did that. So another important fact for you to know in this lesson would be, do you know that many people are shouting right now that water is becoming less and less water is available to people? So is that true, in fact? So is that true that water is really becoming less? Now, let's answer this question together. So if there are some of you who learn physics or chemistry or engineering, then you should know that in all systems, what comes in should go out, right? What comes in should go out. And if nothing comes in, nothing goes out. Or if something goes, basically if nothing comes in, nothing should come out, basically. So here is our Earth. This is one system. And for water to change its mass or volume, some water should be leaving Earth totally. So for water to be less on the whole earth, it should be leaving out to the universe. Do you understand? Out to the universe. But it's not, because we have a gravity pull that attracts all the water to the earth. So water is not, by its quantity, water is not becoming less. Whatever amount of water we had like centuries ago, we still have that water. This is all trapped here on earth, and it does not escape. Even if it escapes, it escapes in very little quantities, because the gravity is so powerful that the whole water wouldn't escape. Yes. So but then why does everyone freak out? Like, why the water is becoming less? Because to us human beings, not only the quantity of water is important, but also its quality. We cannot drink all kinds of water, right? We cannot drink ocean water, or we cannot drink salty water, or we cannot drink water that has heavy metals or some organic toxic things, right? So for us, for human beings, there is a very narrow range of concentrations that are allowed. And basically, when we say that water is becoming less, what we actually mean is that pure drinking water that is good for human health is becoming less. And that is true. That is true. So basically, the pure drinking water is trapped in this ice in Arctic. Also, it's trapped in so where is our mountains? And also it's trapped in this ice coverage of our mountains. So here you can see that here we have the ice and it's trapped here. Basically, the problem is that this water is becoming less. The water in the oceans is becoming more, and that's why some of the places, some of the countries that are located near to the shore are being flooded because too much water. And we, Uzbekistan, Central Asia, we're being drier and drier because our water is becoming less. The water that is for drinking is becoming less. So I would also like you to understand this concept. Yeah. And so we answered to this question. So yes, so this picture also shows this in a very good way, but I wouldn't go into deep explanation because I think everyone covered this hydrological cycle in the school, so you don't have to know a lot about this part. Basically, what happens is that due to climate change, just less and less water is going uphill to our mountains, and that's why they have less precipitation. And if these white things, the ice on the top of our mountains, is becoming less, it means the next spring we're going to have less water flowing from the mountains. And this is truly bad. This is truly bad. So, coming to the end, thank you for those who are sticking till the end. So, why this matter? Why does this matter? Yeah, my grammar. I'm sorry for my grammar. So, why does this matter? So the structure of my lectures is that we learn all the theory, and at the end we apply that theory to something. And in order to use everything that you learned today, let's discuss this infamous case of RLC and what happened to it, and from where its water used to come, and where did it go, and what happened to RLC that it shrank so much, right? So for that, I'm going to make a little magic on my laptop. Yeah. So let me do one thing. Okay. So we need RLC. So here is RLC, nice and dry. Yes. So what has happened to RLC? Let's discuss it in more detail. Do we have time? We have plenty of time. So here is this RLC. I like Google Earth Pro? Because Google Earth Pro has this nice feature of time lapse. So you can look, for example, in Google Earth Pro, you can find your house and look at it 5 years ago or 10 years ago, and find what kind of things were located in that place before your house, for example. And here in RLC, okay, here in RLC we can even trace it back to 1973. Like, I think 1973, even my parents weren't born, but RLC was here in its old place, and here it's nice, it's big, it has a lot of water, right? So this is how RLC used to look like. Yes, and I need this. So let's talk about pre-1960s era time. So this was the era of stability. So what used to happen to RLC before this catastrophe? Basically, as I told, we have two rivers. Here you can see Sirdarya, and here you can see Amudarya. And for RLC to exist naturally in a good, stable way, around 56 cubic kilometers of water need to come to RLC every year, because as you can see, RLC is located in this very arid place, and its surface is so huge, and it's located here the whole time under the sun. So all this water that would come from Amudarya and Sirdarya had to evaporate throughout the year. So 56 cubic kilometers of water coming to RLC, and the same amount of water leaves RLC throughout the year. Yes, so let's say 56 come and 56 go, and that's why RLC is in a good shape. It's not increasing and not decreasing. It's good. Basically, it's good for RLC. Yes. So its volume is around 1,083 cubic kilometers. Its surface area is around 68,000 square kilometers. It's nice, it's big, everything is good. So what happens next? So next is that the whole Central Asia is being invaded and colonized, and we have this idea to enlarge our lands for irrigation. We want to have more irrigation. We have good lands, and we want to cultivate a lot of crops like cotton, wheat, fruits, and so on and so forth. And not only Uzbekistan, but also our neighbor Turkmenistan. So as you can see, Turkmenistan is pretty dry. Yes, it's pretty dry, and it wants to increase its capability to to have agriculture, and that's why from 1954 to 1960s it built big canal that is called Karakum Canal, and it's being originated somewhere here. We cannot enlarge too much because in 1973 imaging quality was not that good. So basically what happens is that they built this very big canal from Amudarya that diverts around 20 to 25% of Amudarya's water to Turkmenistan. And what happens is that less water comes to RLC. And we do simple math. If less water comes to RLC, but the same amount of water is still evaporating from RLC, then the volume of RLC is going to shrink from 1 year to another year, right? So 56 cubic kilometers has to leave, but now not 56 cubic kilometers are coming, but maybe 40 or 45, which means the rest is being taken from the actual volume of RLC, and that's why RLC is shrinking. But the problem of Karakum Canal is not that it was constructed. Turkmenistan has right to take Amudarya's water because Uzbekistan is also taking Amudarya's water. And it's okay, they have the right, they have the people, and people should be fed, right? And they should have enough food in order to feed their people. It's okay. But what was not okay is that they built this canal in a very wrong way. When you build a canal, what you have to do is you should make sure that there will be no infiltration. Infiltration is when water is being uncontrollably passed into the ground, into the earth. So when the canal is not built in a good way, the water doesn't reach its destination, the agricultural lands, but it goes and it seeps through the ground. It seeps through the ground. And in order to prevent it, for example, you can cover the land with asphalt, or you can cover it with cement, right, in order to prevent it from infiltration. But this wasn't done in Karakum, and that's why Karakum, what they did was just made this canal, and that's it. And this canal was literally on earth, on sand, and all the water of Amudarya that flowed through it would just go into the ground. So which means we say to Turkmenistan, okay, use the water, but use the water in a good way, in a proper way, right? But which did not happen. And this was very tragic, this was very bad, and this was one of the problems. It's not the main cause, but this was one of the problems. Yes. So for some information, um, right now, what was researched is that Karakum Canal, there is already little amount of infiltration. Why? Because throughout the years, the river has insulated the bottom of the canal by itself. Yes, because it brings some stones, it brings some plants by itself. So nature healed this slope by itself. Yes. So right now, not that much of infiltration, but in the past there was a lot of infiltration, which is not good. So what happens next is that from 1960s to 1970s we have this rush, which is called white gold, which is cotton. Basically what happens is that in USA they have this economical crisis, and the prices of cotton are raised to a big numbers, and that's why we have very good plans to raise a lot of cotton and use these very good times in order to sell the cotton and enrich the economy. And what happens is that in a very short period of time, the area of irrigated land increases all the way from 4.5 to 7 million hectares, and which means that we're using already more water and less water is coming to Aral Sea. So actually, yes, for example, this is in 1973, this is January of 1973, and then for example, if we come, oh no, so this is already the times of white gold. So right now we just started doing this cotton irrigation, cotton cultivation. What happens next is the collapse itself, is that the same amount of water is being evaporated from year to year, but less and less of water is coming because we are using too much of it and not in a good way. So what happens is that, for example, already by 1984, here you can see Aral Sea that shrank too much. Yes, so already it's not in a good way. I would like to show you in between, but we don't have opportunity to see in between, so only the picture for 1984 is available. So everything is being continued in the old way. We're still using too much of water, and the world gets hell scary when actually the river is being separated into two. The water is becoming so less that the whole lake, the whole Aral Sea was divided into two parts: the northern, the small Aral, and the southern, the big Aral. So here in 1987, you can already see that the sea was divided into two parts. Yes, into two parts, and the upper part is being fed by Sirdarya, and the lower part is being fed by Amudarya. So what's happening next is that from 1990 to 2005, everything is continuing in its old way. And for example, here we can see that everything is being continued still bad. 1991, the collapse of Soviet Union, all countries are becoming independent, and basically it's good news, but it's not that good news for ecology, because when countries are united, the problem of RLC is the problem of all 5 countries. But when countries divide, the problem of RLC is now only the problem of Kazakhstan and Uzbekistan. Yes, and 2 countries cannot deal with such a big environmental catastrophe on their own. So the problem continues. You can see water shrinking, water is becoming less and less and less. Yes, and then basically the whole world is already trying to do something. Yes, they're trying to do something, and the first big action was taken in fact um, by the side of Kazakhstan. So what they decided is that they should do something, and their decision was to build a dam between North Aral, the big Aral, and the big Aral and the small Aral. So for example, in 2005 they built this dam. So here you can see that there is no dam yet, but for example, if we go to 2006, then already there is a dam. Here there is a dam that is being built from this side to this side, and here is, if I'm not mistaken, this should be Sirdarya. Yes. So here is Sirdarya that is flowing to North Aral, and it's still bringing water to North Aral. But Amudarya no longer is connected to Big Aral because we are using too much of Amudarya's water. But Kazakhstan is not using water of Sirdarya, but Kazakhstan lets water of Sirdarya to go to North Small Aral. And then they built this dam in order to at least preserve the small Aral. Yes. And basically, from 2005 till present time, this problem is being continued, and already they're making a pretty good job here in North Aral. You can see that the water is in fact in North Aral is staying, and at times it's even, you can see that it can even increase in its volume. Yes, so at times when it increases in its volume, the dam lets some of the water slip by, and that's why this part of this land has some water, which is good. Yes, and now today is the present time, and this is the picture of Aral Sea today. So once Aral Sea used to be very big sea, a very big lake. Right now it's in this case. Simply why? Because less water is coming, but more water is being taken from the sea by the nature, by the evaporation, right? Yes, so this is application of the theory that you learned today, is that the water is being originated in mountains of Uzbekistan, and it's supposed to go to the Aral Sea. Both big rivers are supposed to go to Aral Sea. Then the water should be collected in Aral Sea and then evaporated throughout the year. And the evaporated water should go back to mountains, and then the cycle should continue throughout the year. And water in that way is being upcycled, renovated, treated, and brought back to people. But what happened is that in between we broke that cycle, and now less water is going to Aral Sea, less water is being evaporated, less water is going to mountains, and less water is coming to us, which is not good. But as I said, water doesn't go away. Water does not disappear. It stays. But where? Where is our water? Where is our water? So if you listen to me very closely, I told you that a lot of water is going here and is being dissipated in this area, right? Because we do a lot of irrigation, we do a lot of agriculture. And when we let this water pass through the earth, what happens is that a lot of water go underground. Yes, and the ground is also a very good filter for water. So what happens is that all the water that doesn't go to Aral Sea, it goes to underground, and we have groundwater, the water that is beneath the earth. And this is also very good water. It goes down and it's being treated by these many layers of earth, of ground, and then it can be returned back to human. For example, in Central Asia, mainly in Uzbekistan, we use a lot of groundwater. Yes, we use a lot of groundwater. For example, in Tashkent already, there are 5 places where we take drinking water for people, and 4 of them are from groundwater resources. One of them is from Bosu Canal, Bosu River, and the other 4 are from underground sources. Yes. So basically, we could say that underground sources of water are the future of Uzbekistan. Yes, because we have a lot of them, simply because we let a lot of water to seep underground, and now we have a lot of underground water that we can use in the future. So by this, I would like to finish our lecture. Yes, and I would like to tell you that you have a homework. So your homework would be to download this Google Earth Pro. You saw that it's really cool tool to use. It's really interesting. You can look at it, for example, in Tashkent. You can look at our mountains. You can see how the water is being... let me make it bigger. You can see, for example, all of these mountains. Look how beautiful they are. And then you can see how this pure, pristine, beautiful water is coming from our mountains, is being originated, and then is being filled here. Yes, so this is our Charvak. So here is our dam. Yes, and here is the Charvak reservoir. And then from here we already have our Churchik River. So what is so cool about Google Earth Pro is that you can see all of these beautiful mountains. You can see our ice here, for example, right? You can even look at how much ice we used to have. Was it more? For example, this is 1984. This is 1995. We used to have a lot more of ice than right now, for example. Yeah, you see. So this is December of 2020. We are supposed to have a lot of ice, but we don't. And then this is December of 1999. Yes, so you can track this all on your own. So I would highly recommend to learn how to use this amazing tool. And you will need to learn how to use this tool, because your homework is going to be to find one water reservoir from Uzbekistan. Already not Aral Sea, because Aral Sea was taken by me, but you should take another water body from here, for example this one, or it can be Amudarya or Sirdarya or anything else, and then you should find about its history, right? And using this time lapse of Google Earth Pro, you should do exactly what I did for Aral Sea. You will switch from one year to another year, and you will be telling, oh, this year this happened, that year that happened. Yes, and basically then what you should be doing then is that you will be just filming your screen. You will put on the screen recording. In the background there will be your voice, and you will be just telling about this river, and just using this time lapse will be describing the history of this river. So this will be your homework. And soon I will send a link for the Google form where you can submit your little history of whatever water body you have in Uzbekistan, and the submission format should be a video. Yes, so everything will be sent. Also, the video recording of this lecture will also be shared with you. So by that, I would like to finish the lecture. Yes, and if you have any questions regarding the problems we discussed and so on and so forth, you can give them now. Otherwise, we can say bye-bye to each other and finish the lecture. Okay, so yes, Stefanos?
Good evening, Nandis. I hope you are doing well. And I want to ask what's the deadline for homework? Because it said that you have 6 days of these lessons, right?
Yes.
It's the deadline.
It's 24 hours. It's until our next lecture.
Okay, till the next lesson.
Yes, the next lesson will be tomorrow 9 p.m.
It's understandable. Thank you for the lesson.
Yes, thank you to you as well. When you speak, yes, you're welcome. You can just, put on the microphone and just answer. Is there a time limit for the video? No, there is no time limit for the video. It depends on you. It can be 1 minute, 2 minutes, 3 minutes, 4 minutes. Yes, there is no time limit for the video. You're welcome.
Thank you very much for lessons. That's all, teacher?
Yes, this is all.
Have a great day. See you tomorrow. Thank you very much for lessons.
Yes, thank you. Great, then. Thank you to everyone and see you tomorrow.